An area of difficulty that is always hard for algebra students is the difference between simplifying and solving with rational expressions. So this is an example of a rational expression, and these directions say to simplify. So right away you should be thinking, I want one fraction, and then I want to simplify that fraction by reducing, if possible. So to get these two fractions combined into one fraction, I must have a common denominator. In this case, my common denominator has to be x, because I need an x, and also x plus 3. So I'm thinking about, what is this first fraction missing? What do I need to multiply by so that it will have a common denominator of x times x plus 3? I'm missing the x plus 3 part. And then I'm thinking, what's the second fraction missing? It's missing an x. So I've got 3 times x plus 3 over x times x plus 3 minus 5x over x times x plus 3. Don't make the mistake of trying to cancel out the x plus 3's in the first fraction. If you do that, you'll go exactly back to the first problem that you started with. It's not going to help you any. In this case, what you need to do is get one fraction. To do that, you need to add or subtract the numerators. So here I've got 3x plus 9, and I'm subtracting 5x. Altogether, I've got negative 2x plus 9 over x times x plus 3. Can I factor the numerator and reduce at all? I can't, so I'm done. If I asked you to solve a problem that looked like that, it would be 3 over x equals 5 over x plus 3. In this case, I'm trying to get rid of the denominators because I can keep it equal. I can balance this equation. I can keep the equation balanced by multiplying both sides. If I multiply the right side by x plus 3, I have to multiply the left side by x plus 3. And I'm keeping the value. If I do it to both sides, I keep the value. But I also have this dividing by x that I want to get rid of. So I'm going to multiply by x as well. So on the left-hand side, I just have 3 times x plus 3. On the right-hand side, I have 5 times x. Now I would solve this like normal. So x equals 9 divided by 2. My restrictions are negative 3 and 0. So 9 over 2 is a perfectly good answer. In the first problem, if I had tried to reduce the denominators by multiplying, I would lose the value. Because if I had a fraction like 3 over 5, and I subtract 5 over 8, if I were to multiply both of these by 40, I would get 24 minus 25, which would give me negative 1. If I take 3/5 and I subtract 5/8, hopefully you know that you will not get a whole number. I'm going to get a fraction of something. So I won't be able to get a whole number. It has lost its value. I have changed the value of it by multiplying by the denominators. So that won't work. That's why I have to keep the denominator in the first example. Okay, let's try 2 more. Here I've got to simplify and I've got to solve. They look similar, but they're different. So in this case, I need to find the common denominator. Common denominator is x plus 2 and x minus 4. In number 4, you can also find the common denominator. X plus 2, x minus 4. They're the same common denominator. In number 3, I need to multiply by x plus 4 to get a common denominator, to keep it the same. The second fraction I need to multiply by x plus 2. The third fraction I need to multiply by both, x plus 4 and x plus 2. So I'll get 3x times x plus 4 plus 2 times x plus 2 plus 3 times x plus 4 x plus 2 all over x minus 4, oops, should be an x minus 4, my bad, x minus 4, x minus 4, x minus 4, and this one too. Okay, x minus 4, x plus 2. Now if I want to simplify this fraction, I'm going to distribute and simplify the numerators. So I have 3x squared minus 12x plus 2x plus 4 plus 3x minus 12 times x plus 2. So I still have some more multiplying to do on that part. So now I'm going to combine some like terms. 3x squared minus 10x plus 4 plus 3x squared plus 6x minus 12x minus 24. Oops. Over x minus 4, x plus 2. I'm not multiplying the denominator because I know at the end of this I'm going to try to reduce. So I'm going to try to cancel one of those factors. So I'm leaving the denominator for that reason. Do want a little more space though. Maybe not quite that much. Okay, so now I want to combine like terms again. So 3x squared plus 3x squared is 6x squared. Minus 10x plus 6x minus 12x is minus 16x. And then positive 4 minus 24 is a negative 20. Divided by x minus 4, x plus 4. So I'm factoring by first finding the greatest common factor, which is 2. So I have 3x squared minus 8x minus 10. So then what are the things that multiply to negative 30 and add up to negative 8? That could be 1 and 30, 2 and 15, 3 and 10, 5 and 6. None of those multiply to negative 30 and add up to a negative 8. So this cannot be factored. So this is my final answer. Okay. So now let's look at this problem. What do I do with the common denominator here? Now I multiply by the common denominator so I can get rid of some fractions. So multiply here, and I have 3x times x minus 4. That's all that's left. Multiply here, and I have 2 times x plus 2. Multiply on this side, and I have 3x plus 6 times the x minus 4 again. So now I distribute. I want to get it equal to 0, right? So I have 3x squared minus 10x plus 4 equals 3x squared minus 6x minus 24. So 3x squareds are gone. I'm going to add 10x. I'm going to add 24. Add 10x. Add 24. So now I have 4x equals 28, which means x equals 7. Don't forget to go back and check your answer. So if I have x equals 7, will that make the denominator 0 at all? So it would be 7 plus 2 will be 9. 7 minus 4 will be 3. So it doesn't hurt my restrictions. So I'm done.